Hi there, this is Penelope. This is a repeat of the last slide in the previous video. We ran out of time, so it cut short. We've looked at how a vector can be multiplied by a scalar. And that's the idea where if you have 3 times a, it's 3 times longer than the vector a. But what we're going to look at now is a different kind of product. It's where a vector can be multiplied by a vector, and we talk about it as being a scalar product. So this is multiplication by a scalar, but we're also now going to look at a scalar product. And I've written out the definition here. And we'll look at an example, but first we need to look at I dot I. And remember that was in the previous video. If we've got I dot I, by the definition above, it's the length of I times the length of I times the cosine of the angle in between. Now if I and I, that the angle in between is 0, so we've got that, which means we've got 1, because I is just 1 unit long, times 1 unit long, times, and if you look up the cosine of 0, it's 1, so it's 1. Similarly, what if we looked at I dot j? Now that's going to be the length of I, which is 1, times the length of j, which is 1, times cosine of 90, because that's the angle between them, that's I and that's j, and they're each a unit long, and the cosine of 90 is 0, so ij is 0, and further we could say that j dot j is equal to 1 and j dot I is also equal to 0 by the same proof. Let's have a look at an example. If we've got a is equal to 3i plus 2j and b is equal to 4i minus j, then what if we were to find a scalar product b? So by definition it would be 3i plus 2j times 4i minus j. Okay, so using FOIL, then we've got 3i times 4i minus j plus 2j times 4i minus j, and multiplying that out, that would be 12i minus 3ij plus 8ji minus 2jj. Now from the previous slide we know what they are, so therefore that's equal to 12 times 1 minus 3 times 0 plus 8 times 0 minus 2 times 1, which is 10. So we could also think that if a equals a1i plus a2j, and if b is equal to b1i, just standing in for numbers, plus b2j, then a dot b is equal to a1b1 plus a2b2, because of the way these just kind of pan out. So if we had an example, a equals 4i plus j and b equals 2i plus 3j, if we were to find the scalar product AB using this way, we could say that AB is going to be 4i plus j times 2i plus 3j, which is going to be, well, work it out. You can do it, stop the video and work it out. It's 11. But we also know that A dot B is equal to the length of A times the length of B cos theta. So if we wanted to find the length of the size of the angle between, we could work out the length of A, which would be 17, root 17, and the length of B, which is root 13. And then we could say, well, okay, 11 has got to be equal to root 17 times root 13 times cos of theta, because that's the other definition of it. And then we could figure out that cos theta by algebra is equal to 11 over square root 17 times the square root 13, which is, use your calculators for that, 0.739. Now going backwards, that allows us to work that theta is actually just over 42 degrees.